Back in 2017, Earth had an encounter with something extraordinarily unusual. At that moment, we remained unaware, but our world had received a visitor from the distant reaches of space beyond our solar system, originating from another stellar region. This object defied anything previously observed in our experience. Years of investigation would be required before we could comprehend the true nature of what we had witnessed. Now, as we move through 2025, history appears to be repeating itself. A new enigmatic traveler is making its approach toward our sun. This time, however, we have advance warning of its arrival. The situation is about to become even more peculiar than before. Let's begin with the original discovery. This entity is known as Oumuamua. It holds the distinction of being humanity's first confirmed detection of an interstellar object, signifying its origin from beyond our solar neighborhood. The object had journeyed through the cosmos for countless millions of years before its fateful meeting with our planetary system. Despite this epic voyage, its arrival took us completely off guard. By the time our observations confirmed the object's identity, it had already completed its nearest pass to our sun and was departing our solar system, returning to the emptiness beyond. The name Oumuamua derives from the Hawaiian observatory responsible for its initial detection. Their first assessment classified it as simply another comet, but further examination revealed the absence of the characteristic tail typically displayed by comets traversing our solar system. The logical conclusion shifted. It must be an asteroid. Yet, this particular object exhibited behavior far too peculiar to be merely another drifting space rock. Its velocity was excessive. This speed provided our first clear signal that we were observing something from interstellar space. Every object residing within our solar system remains bound by the sun's gravitational influence. The planets, comets, and asteroids, all of us simply orbit around this immense gravitational anchor. Breaking free from the solar system would require acceleration, achieving what we term escape velocity. This threshold varies depending on proximity to the sun. Calculated from Earth's position, escape velocity measures approximately 42 kilometers per second. Our initial observation of Oumuamua occurred as it traveled beyond Earth's orbital path, already heading away from the solar system, and it was traveling at 87 kilometers per second. This speed far exceeded what would be necessary to remain captured by solar gravity. We classify this type of path as a hyperbolic trajectory. What makes this particularly fascinating is that prior to passing Earth, Oumuamua had approached so near to the Sun that it ventured inside Mercury's orbital radius. What proves even more intriguing is that such intimate proximity to such a powerful gravitational source should have decelerated the object significantly. However, our observations revealed that as Oumuamua retreated from the Sun, it actually gained speed as it exited the solar system. This characteristic inspired the object's name. In the Hawaiian language, Oumuamua translates to the first to reach out, or alternatively, the first distant messenger. We typically simplify this translation to mean scout. The layers of strangeness continue to accumulate here, and we've only begun to scratch the surface. If this object were simply an interstellar asteroid, in other words, just a rock, then its motion should conform to established physical laws. Physics dictates that a close solar pass would have reduced its velocity. Since that deceleration didn't occur, some additional force originating from within the object itself must have influenced its speed and trajectory. This reality makes it physically impossible for this object to be merely a rock. It must be something fundamentally different. The next tier of peculiarity involves not only Oumuamua's unprecedented movement through space, but also its remarkably strange appearance while in motion. When we attempt to generate images of distant celestial objects, our only available data comes from the quantity of sunlight reflecting from their surfaces. Massive bodies such as Saturn and Jupiter cast back enormous amounts of light, enabling clear observation despite their tremendous distance from us. When dealing with something comparatively small, like an asteroid, all we perceive is a faint point of light bouncing off that object's surface. The majority of asteroids exhibit low reflectivity because they consist primarily of rock, and their shapes tend toward spherical forms. Consequently, we anticipate observing a relatively steady and faint reflection. Oumuamua defied these expectations. First, it proved to be an exceptionally luminous object, highly reflective, suggesting its composition probably differs from rock. Second, as we tracked this point of light across the sky, it failed to remain constant. Instead, it pulsated between bright and dim states, cycling back again every 7 hours. This behavior indicates the object cannot possess a round, asteroid-like shape. We were observing both an elongated side and a shortened side. This evidence led astronomers to the improbable determination that the object likely possessed an elongated narrow shape resembling a cigar, slowly rotating end over end during its journey through space. Although an alternative explanation might involve a disc-shaped object, wide, flat, and thin, also tumbling as it traveled. However, informing people that you've witnessed a flying saucer arriving from another star system might begin to sound somewhat irrational. Unless, of course, that represents exactly what occurred, in which scenario extraterrestrial intelligence. Could Oumuamua be an alien spacecraft? This is the juncture where sensationalist television programs would attempt to convince you that it is, and theoretically it could be, but our purpose here involves presenting established facts and allowing you to form your own conclusions. The situation is undeniably peculiar. People become fixated on Oumuamua's appearance, and it certainly is unusual. However, don't overlook the fact that the object's inexplicable velocity change truly makes it so remarkable. This acceleration is what lends some credibility to the extraterrestrial hypothesis. Here's the fundamental issue. Comets normally accelerate during solar passes because comets essentially consist of massive ice chunks originating from the deep reaches of our solar system, the Oort cloud. That distant region contains all manner of strange, random frozen materials. It resembles the forgotten contents at the bottom of your freezer. Occasionally, one of these objects curves through the inner solar system, and as it nears the sun, the ice begins transforming into gas. We call this process sublimation, which differs from melting because the ice never transitions through a liquid phase. It converts directly from solid to gaseous state. This phenomenon produces the comet's fuzzy halo, which we call the coma, along with its extended tail. Significant amounts of dust also release as the ice sublimates. Regardless, the key point is that all this expelled material functions exactly like a spacecraft's thruster system. When the sun heats one side of the comet, more gas ejects in that particular direction, and the resulting force propels the object, altering both its orbital path and velocity. Yet, Oumuamua displayed none of these typical comet-like visual features. No coma, no tail, no observable outgassing whatsoever. Despite this, it exhibited behavior very characteristic of a comet, which led certain people to conclude that this might actually be a spacecraft equipped with propulsion systems. Let's examine Oumuamua's origin point. Its trajectory points back toward the star Vega. It represents the most luminous object within the constellation Lyra, which appears in our northern celestial sphere. Vega isn't just some arbitrary star. Astronomers have conducted extensive studies of it over many decades, and it frequently receives the designation of being the most significant star in our sky besides the Sun. This fact carries particular interest. 14,000 years in the past, Vega actually served as Earth's northern pole star. The North Star, a fixed point of light in the nighttime sky that has probably served navigational purposes since humanity's earliest days. The identity of the North Star shifts gradually over time as Earth slowly wobbles through space. Currently, Polaris holds that position, but the role will eventually return to Vega around the year 14,000. To be clear, no evidence confirms that Oumuamua originated from the Vega star system. It simply arrived from that general direction, which coincidentally matches the same direction our own solar system currently travels. Therefore, just as much as Oumuamua encountered us, we also somewhat encountered it. We'll explore galactic motion more thoroughly in a moment. As Oumuamua curves around our sun, it begins flying directly toward Earth's position. This represents where some observers would argue that the coincidences truly begin accumulating. This strange object arriving from a distant yet historically meaningful location in the galaxy, exhibiting this peculiar and inexplicable behavior, and it passes right by our planet. Proximity remains a relative concept in space, of course. At its nearest point, it remained 24 million kilometers distant. For perspective, our moon orbits at 400,000 kilometers distance, making this roughly 50 times the moon's distance. Perhaps an ancient alien probe for all. An advanced civilization possesses the capability to observe us from such great distances. Our telescopes first identified Oumuamua at this location several days following its closest Earth approach, already departing back toward interstellar space. Despite its relatively close passage, we never truly obtained adequate opportunity to study Oumuamua or definitively determine its exact nature. Various proposals have been discussed regarding launching a probe to pursue Oumuamua for closer study, but the object travels at such tremendous speed and possesses such an overwhelming head start that no conventional chemical rocket engine could possibly overtake it. We would need to devise some intricate orbital mechanics maneuver where a probe would fly to Jupiter, utilize a gravity assist from that planet to fall toward the Sun, then fire its engines during the solar flyby to catapult itself out of the solar system along Oumuamua's trajectory. That scenario won't materialize. If Oumuamua had represented the single interstellar object we would encounter during our lifetimes, then such an ambitious mission might have warranted serious consideration. However, shortly following that initial encounter with a fragment of the distant galaxy, something unusual began occurring. We received another visitor. In 2019, a second interstellar object was identified. This discovery was named Borisov, honoring the amateur astronomer who made the initial detection. Similar to Oumuamua, Borisov arrived on a hyperbolic trajectory, traveling too rapidly for solar capture. Borisov also originated from the same general direction in the northern sky, this time emerging from the constellation Cassiopeia. Unlike Oumuamua, however, Borisov unquestionably qualifies as a comet. It possesses the appearance of a comet. It exhibits comet-like behavior, and according to our best analysis, it consists of very similar composition to the comets native to our own solar system. Still quite remarkable, but nothing particularly mind-blowing, although it remains noteworthy that we so abruptly transitioned from observing 0 interstellar objects throughout the entire history of astronomical observation, and then we received 2 of them within a span of 2 years. And then there were 3. This represents our most recent visitor, 3I Atlas, meaning the third interstellar object discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which operates as an autonomous robotic survey detecting near-Earth objects. The detection occurred on July 1st at a distance of 4.5 astronomical units from the Sun. An astronomical unit, abbreviated AU, represents the average distance separating Earth and the Sun. We employ this as our solar system's standard measuring unit. Therefore, 3I Atlas currently sits 4.5 times farther from the Sun than Earth's position, placing it just beyond Jupiter's orbit, though still considerably distant from Mars. The exciting aspect of 3I Atlas involves catching this object during its inbound journey into the solar system. We're presently observing its approach toward the Sun for the very first time. What initially distinguished this object was its substantial size combined with exceptional velocity, significantly faster than Oumuamua, and it arrives from a completely different direction. While we essentially collided head-on with Oumuamua and Borisov, Atlas approaches from the side, resembling a T-bone collision. This trajectory indicates Atlas originated in an entirely different region of the galaxy, somewhere distant, ancient, and vastly unlike our own cosmic vicinity. We typically visualize our Milky Way galaxy from this perspective, a top-down view. Our location sits right here, positioned approximately midway between the galactic core and the outer rim. From our actual vantage point, however, the galaxy appears more like this, a side profile view. We observe a large sphere-like core, also designated as the bulge, surrounded by a relatively flat disk composed of stars, planets, gas, and various other matter, all swirling in spiral patterns. The overwhelming majority of those stars concentrate in the very center of this plane. We designate this region as the thin disk. Our Sun resides within this area. However, just above and below the thin disk exists a far less dense and more dispersed layer of stars, designated as the thick disk. Since less stellar formation activity occurs in this region, objects within the thick disk tend to be much older remnants from the galaxy's early epochs. Beyond the thick disk, random pockets of star formations exist that we call globular clusters. Those represent truly peculiar formations, but we won't explore them today. Understanding this structure matters because 3I Atlas appears to have originated from the thick disk. If this assessment proves accurate, then this might be an incomprehensibly ancient object. At the upper estimate, it could exceed 7 billion years in age, predating even our own solar system. This age alone makes 3I Atlas a profoundly interesting object. However, 2 additional factors deepen the intrigue even further. The first factor is size. This object possesses truly impressive dimensions. Initial assessments estimated the diameter at up to 20 kilometers across. As our observations of Atlas continued, we began comprehending more clearly what we were examining. It quickly became apparent that this object does possess a surrounding coma, a cloud composed of gas and dust, indicating that it's not a solid object like Oumuamua. It actually qualifies as an interstellar comet similar to Borisov. The coma measures 20 kilometers in width, but the nucleus, the solid mass of frozen material at the center, could still measure as large as 11 kilometers across. This would make it 10 times the size of Oumuamua and 5 times larger than Borisov. They're getting progressively larger. The second factor, and probably the most peculiar fact about Atlas, concerns its trajectory. Since this object approaches us from the side, it will have the opportunity to pass several planets during its transit. The object's nearest encounter will occur with Mars, approaching within approximately 28 million kilometers. Subsequently, it will pass relatively near Venus, at about 97 million kilometers distance. During its outbound journey, 3I Atlas will fly past Jupiter at a distance of just 53 million kilometers. It's certainly enjoying some quality sightseeing during this visit. Coincidentally, however, 3I Atlas will completely miss Earth. We'll actually be positioned on the opposite side of the Sun as the comet traverses the inner solar system. This positioning means our telescopes will lose visual contact with the object in October of this year, and we won't regain observation capability until December, at which point it will have already completed its closest solar approach and will be departing the solar system. Similar to the strange behavior exhibited by Oumuamua, some observers would argue that the planetary grand tour of 3I Atlas represents no coincidence, that it might reflect the intentional behavior of an alien probe attempting to learn as much as possible about our solar system, while simultaneously avoiding close observation from the only inhabited planet by concealing itself behind the sun. Even maintaining an open mind, that interpretation feels like quite an extreme stretch. If an ancient alien species actually dispatched a probe across such vast interstellar distances, traveling for billions of years, possessing the opportunity to examine a planet covered with life and home to an advanced civilization, why would they simply avoid us at the final moment? Regardless, the exciting aspect of 3I Atlas is that we still have several months to observe it as. It continues approaching the inner solar system. In time, much of the mystery will transform into knowledge. Unlike Oumuamua, we might still possess a realistic chance of intercepting Atlas. We probably cannot construct and launch anything from Earth quickly enough, but we do maintain pre-existing spacecraft in orbit around Mars and Jupiter. A potential scenario exists where one of the Mars orbiters could maneuver outward attempting to approach Atlas as closely as possible. There's even a scenario where the Juno spacecraft could depart from Jupiter orbit and rendezvous with Atlas in deep space next spring. That outcome remains unlikely, but it would certainly be exciting if only to definitively confirm what we're actually observing. Had we possessed the capability to do the same for Oumuamua, we would probably have far more answers and considerably fewer questions today. However, even without dispatching a probe, we still maintain some quite reasonable hypotheses. Assuming Oumuamua wasn't an alien spacecraft, it could still qualify as a comet. If a comet simply consists of a chunk of frozen material, then no rule dictates what that material must be. In our solar system, the comets we observe typically consist of frozen water, which sublimates into gas and creates the signature tail because water vapor generally remains easy to observe. Similar to steam, for example. Not all gases possess such visibility, however. Nitrogen comprises nearly 80% of the air we breathe. It's colorless, odorless, and generally imperceptible. Yet it proves essential for plant growth, making it important matter. One very familiar object consists almost entirely of nitrogen, Pluto, the object formerly classified as a planet. Most of Pluto's surface consists of nitrogen ice, which substantially contributed to why Pluto received planetary classification initially, because frozen nitrogen exhibits high reflectivity. When you observe through a telescope, Pluto appears large and bright, but it actually measures less than 2,500 kilometers across. It's considerably smaller than our moon. Now imagine this scenario. Pluto suffers an impact from a giant asteroid or a rogue planet and fractures into jagged fragments. One fragment launches toward the sun at incredible velocity. What we now have is a chunk of frozen material traveling from the outer solar system toward the interior, essentially a comet by most definitions, except this one consists almost entirely of nitrogen ice. It will begin melting, or technically sublimating, as it approaches the sun, and the ice will convert to gas. However, because nitrogen remains invisible and non-reactive, we won't actually observe any coma or tail emanating from the object. That doesn't mean it isn't present, though. It is. As the Pluto fragment approaches the sun more closely, increasing amounts of gas release, and the object's natural propulsion system activates. Throughout this entire chaotic process, the sun's gravity ultimately flings the fragment straight out of the solar system and into the void of interstellar space. That's Oumuamua. If that type of scenario played out in some distant star system, perhaps the Vega system, and ejected some unusual shard of frozen nitrogen from a shattered dwarf planet, and then that object entered our own solar system and passed our sun, then it probably would have appeared and behaved very much like Oumuamua. Alternatively, aliens constructed a 100-meter-long, cigar-shaped tumbling space probe and launched it at our solar system, only for it to pass somewhat close to Earth, but not actually very close, and the and simply fly away without really accomplishing anything at all. This is precisely why it proves so important that we can dedicate substantial time to studying 3I Atlas, because it enables us to eliminate many of these known unknowns. We stand to gain tremendous knowledge about how the universe actually functions, the natural processes operating on a scale so unfathomably more massive than our own minuscule existence on one pale blue dot. The most interesting discoveries still lie ahead. Stay tuned.